Hello, I'm going to be talking through this week's project, which is energy generating speed bumps. Our problem statement is that a member of the Department for Transport within the UK has had the idea that speed bumps for roads could be used to generate energy. Further, they believe that the energy generated could be used to power street and road lighting. An investment firm is interested in funding the idea and have engaged your group as scientific consultants to conduct a feasibility study. Your job, well, our job, is to provide an independent assessment of the idea and present fully justified and reasoned arguments for and against the idea. So, what are we going to tell them? For our initial model, we're going to be using the work done equation. And as can be seen from the slide, one car is able to power one light bulb for 3.68 seconds. However, as can be seen from this slide, there are ways of making the light bulb lit for longer. If we place the speed bumps 30 metres apart, the light bulb can be lit for a much larger amount of time. There are also other ways of increasing the effectiveness of the speed bumps, which I'm going to let you quickly read through now. However, there are a potential few problems, such as if the car remains stationary, no more power will be produced. But how many cars do we need? If we presume that one speed bump can generate 335.7 joules of energy, which is enough to power 3.68 seconds of energy from one light, we can calculate the average amount of cars we would need to generate this amount of energy. As can be seen from this slide, 7,827 cars are needed, and on average, a car must pass over the speed bump once every 11.03 seconds in order to produce enough energy. And here on this slide are some similar statistics. As can be seen on this slide, there are some things to consider, such as more energy will be needed during the winter compared to the summer, as the streetlights will need to be lit for longer. Also, 2 speed bumps may be used to power one streetlight. However, after doing further research, it can be shown that this model is not really economically viable, as it would take over 100 years for the speed bumps to repay their cost. Although we could redesign our speed bump, adding an extra element in, which is speed bump powers a generator which could produce more energy. However, we have done some research online and had now found other alternatives. There are some ramps which cost between 20 and 55 grand depending on the size, which consists of a series of panels set in a pad which virtually flush to the road. As the traffic passes over it, the panels go up and down, setting a cog in motion under the road. This then turns a motor which produces mechanical energy. A steady stream of traffic passing over the bump can generate 10 to 36 kilowatts of power. The bumps can each produce between £1 and £3.60 of energy for an hour for up to 16 days, or between £5,840 and £21,024 a year. However, as can be seen on this slide, there is some interest in powering larger areas such as motorways. Using a network of speed bumps of size 5 centimeters and compression of 1 gives 3.68 seconds of power from one bulb. As can be seen from this slide, we would therefore need 26 speed bumps to produce the necessary amount of energy or power from 76,700 cars. We would probably recommend having 30 speed bumps to compensate for slow days. We now hit the problem of trying to be able to store the power. So, using 30 speed bumps, we could generate the power during the day from the cars passing over them and store them in capacitors for when the lights need to be switched on. Energy will need to be transferred from kinetic energy. It will be needed to be stored in some way, as the times the speed bumps will be produced, the most energy is in the daytime when the streetlights aren't needed. Although this idea is theoretically viable, there are still some things to consider, as can be seen on this page, such as the cost of labour, installation, maintenance and repairs may affect how efficient our speed bump idea is. Would it have public support, more speed bumps on the road? What if a car remains stationary on the bump whilst it's stuck in traffic? These are the things which need to be considered, but overall this idea is viable.